The following presentation was made possible by the Alltech Media Group, a Southern California multimedia company providing exponential branding and marketing services to all their clients. The Alltech Media Group understands the value of the 3W strategy, providing their clients proven, trackable results. Let us make it easy for you to grow your business. Visit alltechmedia.com.
Hello and welcome to Energy Independence Magazine. I'm your host, Dwight Cromie. Today we're going to be speaking with Adam Webster, the IT Director for the Inland Empire LMCC. And we're going to be talking about encryption and privacy security for your information. Welcome, Adam.
Hi.
Adam, can you tell me why is encryption and security, encryption for privacy important, and who is it important to?
Well, encryption helps protect your privacy and your data, your information, from anyone you don't want to access it. It helps you remain private from prying eyes. There's been a lot of talk recently about the NSA and government agencies being able to access private information, but they're not the only ones that are trying to get your private info. There's corporate espionage. There's malicious criminals and other types of hackers that are trying to steal your personal information, your social security numbers, those types of things for identity fraud. So using encryption can ensure that the data that you want to keep safe or secret stays that way.
And who exactly would use that encryption software? Would it be a CEO, say IBEW number? Who is that encryption for?
I personally encourage everyone to use encryption because everybody has stuff that they want to keep private or prevent other people from taking that information, like, for example, social security numbers. Anybody can be subject to identity fraud or identity theft. So I encourage everyone to use encryption whenever possible. Let me put it that way. Of course, it's not always as convenient as we want. It can't always be used, but whenever it is convenient, whenever it's possible, I encourage everyone to use it.
And how does one go about using encryption software or encrypting their information? Say I'm a NECA contractor and I'm trying to send a proposal, or I'm sending a pre-proposal to someone else in a different office and I only want their eyes to see it. How do I go about encrypting that information?
Encrypting communications with websites is fairly simple. Encrypting your own information at rest, say on your hard drive or on a flash drive, can be a little more complicated. But before I jump to that, let me talk a little bit about what encryption actually is. What encryption is it's scrambling the data. For example, if you had a message that said attack at dawn and you wanted it to be scrambled into something just incomprehensible gibberish, you would use something that's similar to a decoder ring. It's, of course, much more complex than that for modern encryption, but the concept is the same. A decoder ring simply takes one set of letters and numbers and substitutes another set. Now, what that does is it makes it unreadable for anybody else who stumbles on the message without the proper decoding code or password. And what that does is that protects you from prying eyes trying to get that information. When you're talking to a website, or I'm sorry, when you're logging onto a website, it's a lot easier to encrypt your data. You simply need to look for the green padlock at the top left of your web browser, and you can click on that padlock in most modern browsers to take a look at extensive information that verifies the identity of the website, that tells you, yes, this is really google.com that you're accessing. Now, once you've connected to that website, it uses an encryption technology known as TLS, Transport Layer Security, also known as SSL, and it automatically encrypts your information in transit to that website. So anybody trying to snoop on like a local area network, say you're at Starbucks and you want to connect to your Gmail account and check your email, Once you connect using SSL, your communications with Google become scrambled. So other people on the Starbucks network can't see what you're saying in your emails, what you're typing into your computer. If they're not, then they can. So like a regular local area network, say a Starbucks, you were sending communications to a website that is not encrypted, other people on the network can see in plain text everything that you're typing in and sending to the website. So that's why encryption is important when you're communicating directly with a website.
So that's you're not so much concerned about the Wi-Fi at Starbucks as you are about the site that you're actually visiting,
Exactly.
such as Gmail.
Yeah. Now there are limitations to this. Keep in mind that only the information is only encrypted up to Gmail, up to Google. So for example, once Google gets the information, they decrypt it on their end. So they take your email and then they decrypt it and they have that information. One thing that you may want to keep in mind is that in email, encryption is not generally used very often, which can cause problems. So if you were to send a message with sensitive information through Gmail to somebody else with a different email, once it leaves the Gmail servers, it becomes decrypted into plain text. So generally relying on SSL encryption for your email messages is not a good thing. You want to encrypt the contents of the message as well. We'll talk about tools to do that. One tool is called PGP, and we'll go over that later in depth on exactly how to do that. But it's important to note that the company that you're communicating with over the SSL connection does have that data. For example, you send your credit card number to a company over an SSL connection. Nobody on the local area network can see your credit card number, but the company you're sending the information to does have the number. So always make sure that if you're sending sensitive information to a company over the internet, you have some level of trust with that company. You know that they're reputable, they're not going to misuse your information.
Okay. So getting back to encrypting the file, I want to send an encrypted email to my CEO back in New York, and I want this to be a private conversation. Mm-hmm. How do I go about encrypting that email?
You would use an encryption tool to encrypt the text of the email. The tool that I most recommend is called GPG, and it's called GNU Privacy Guard, which is a completely free application that allows you to encrypt the text of your email. You can download it from the internet. We'll go over actually using that tool in a later segment, because it's actually, there's a fair amount of setup that I'll have to walk users through. Now what that does is that completely encrypts the text and or attachments to the message. The only way that the user will be able to read that is if they have the key that you've sent them and you've verified their identity. We'll get into exactly how you do that using the software, like I said, later. But what that does is the message itself will not be readable by anyone except the person that you intend. Keep in mind, the word metadata refers to the email that message is coming from and the email that message is going to, as well as the time of day or date it was sent. So not everything about that communication remains private. Sure, the text of the communication, the content of the message is private, but what email it was sent from, what email it went to, that will be known by anybody on the network or anybody that cares to look.
So that's where, say, an individual is working for a company and they're maybe looking for a new job and they're encrypting the information to that new employer. If I'm the employer of that employee, I can say, well, you know what, regularly emailing my competitor, I need to know what's going on.
Exactly, that's metadata. So if you can see that somebody's emailing your competitor, even if you can't read the message, you know the metadata. You know who they're talking to when they're talking to them.
Now, how does the person I'm emailing, say my CEO in New York, how does he unencrypt the information I sent him?
There are two ways to do this. One is through public key technology, which is a technology that allows you to verify their identity, and they will be the only person able to access that message using their own password. The second way is through a shared key. So for example, if you encrypted a file using an encryption technology and then sent that file to them, you could read them the password over the phone or use some sort of a second channel to send them the password, and they would know that password and be able to decrypt the file that way.
How does this relate to the recent news that we've heard about the government? I don't want to say spying on our emails, but having access to our emails. How for those who don't want even the government to see what they're doing, how does that assist them?
Well, it's very important to keep in mind that if something is not secure, completely secure, it's simply not secure. So if the government can get into it, other people can get into it. Sure, the government may have certain secrets that only they have, but obviously those are starting to get out. So we want to know that the technology we're using to make our communications private and secure are completely private and secure. Nobody can access them, whether that be the NSA or malicious hackers, criminal organizations, corporate espionage, for example. Large corporations competitors can hire security professionals to try to get information that's sensitive to a corporation from their competitors. The way that this applies is that we want to know that our communications are secure to everyone else. The way to do that generally is to use open source software. What open source software is it makes the source code or the programming behind the software available for everyone to see. So you know what's in the software, you know there are no secret backdoors to the software. Everyone can see the way the software works. GPG, the encryption tool for email that I mentioned earlier, is one of those types of software. One thing I'd like to touch on, we've been talking about communications, encrypting our communications with websites, trusting the website that we send our information to. There's another layer of encryption of your data known as trust no one or at-rest encryption. What that is taking the hard drive and all the information on your computer and encrypting it. The reason we want to do that is, for example, say you have a database of important customer information, your customers' credit card numbers, their social security numbers, or any other sensitive customer information. If that computer is stolen and the hard drive is not encrypted, the person that has the computer can simply copy all the information off and they have it. That's why it's important to encrypt entire drives or sensitive areas of drives. And the way you do that is using open source encryption software. One of our favorites is TrueCrypt. We'll get into the way you use that later. And what that does is that ensures that only the person with the password can access any of the information on that drive or that computer. No one else will be able to get in, even if they have the physical drive. What that also helps you do is protect your cloud information. A lot of people, the cloud, quote unquote, is really just information on companies' servers on the internet, like say Google's servers or Amazon's servers. They have that information on their computers. Now, if you wanted to back up your information there, you'd want to make sure that if something happened, somehow that information got out of the hands of Google or Amazon, no one else would be able to get into it. The only way to do that is to encrypt it before you send it to the internet. Then only you will be able to get into that information no matter what.
Is there software software programming that helps you do that? Because I think that's relatively important.
Exactly. TrueCrypt is our favorite because TrueCrypt is open source, as I mentioned before, so everybody knows how it works. It's freely available, and it can encrypt entire drives as well as thumb drives, flash drives. It can encrypt just about any information that you need it to.
And if our viewers want to look up TrueCrypt on the web, where do they go?
TrueCrypt is available at truecrypt.org. That's truecrypt.org.
Okay.
And I highly recommend, if you use the software, send them a donation because they do work off of donations.
Now, again, that relates to your tablets, because and it's funny that you mentioned that. I just recently talked to an attorney who said he had left his tablet on the plane and he thought it was gone. And he actually had that tracking software that told him where his iPad was, but it never got turned on until 3 weeks later. All of a sudden it got turned on. And so he was terrified because he had confidential legal information on that iPad. Fortunately, it was found by the airlines. Tells you how fast they clean their airplanes, but it was found in the back seat of or in a seat. So can that also protect
Now,
things like
encrypting portable devices like tablets is a little more difficult to encrypt the entire device. The best way to secure those type of devices is, or at least the easiest way to secure those type of devices, would be to use the security feature that locks the tablet to automatically wipe the tablet if an incorrect code is put in more than, say, 5 to 10 times. Now, what that does is you back up your tablet to your local computer, or you have a backup of it somewhere at a secure location. Then when you're out in the field, you have to use your code to unlock the tablet. Now, if you lose the tablet and somebody else gets a hold of it and they try the wrong code a few times, the tablet will automatically delete everything on the device. That's one of the best ways to secure your mobile devices like tablets or phones.
or encrypt the information on the device?
Yeah, it'll delete all the information on the device. And then, even if that happens, you have a backup at home, so you can get another device and just, restore from that backup, or if the device is returned to you, you can put the information back on the device and know that it was safe.
Okay, we do have a question. Would security be different on my cell phone or tablet?
That's basically the same idea. There are some encryption programs for cell phones or tablets, for example. Like we were talking about email encryption. If you wanted to secure your communications via email, you can use an application for your iPhone or tablet. Let me see, do I have my iPhone around? I just found one recently. There are applications that allow you to use GPG to encrypt your emails on your tablet or iPhone when you send them. So, you can look for those type of tools in the App Store.
I'm one of those individuals with a very, very short memory span. And having even 10 different passwords in my head probably is not going to work. You had talked about ways that for individuals in using, say, this encryption software can store all those different passwords, because I think this is going to be relatively important, because each email or each correspondence, you're probably going to want to use a different encryption code.
Exactly.
Or at least for that individual that you're working with. How do I keep those straight? Because again, for me, 2 or 3 passwords and I'm in trouble.
I totally understand. I'm glad you touched on this, because no matter how strong your encryption is, if you use a very weak password, people can still get in. The reason is because there are powerful computers and databases of passwords out there now that hackers can use to automatically attempt just about every password in the dictionary, on top of databases of passwords that other people have used, called a rainbow table, to try to break in. That's why it's important to use long passwords. Length is more important than complexity, actually. We found from recent research that the longer you make your password, the stronger it is exponentially. So it's more important that you imagine your password as a passphrase, for example, a string of words or a string of data that's longer than, I recommend at least 12 characters long. Now, the best way to keep track of all that information, like you said, if you use the same password everywhere, once that password is stolen or somebody has access to it, they have access to all your stuff. So the way to handle that is to use a secure password management software. LastPass is my favorite. There's also an open source alternative called KeePass. That's KeePass. That's available at keepass.info. And what that software does is it allows you to use one secure master password, and you use that to encrypt a database of passwords. This allows you to have that database of passwords be completely random strings of data, that if somebody stole that password, they really wouldn't have anything, because they'd have a random string of information that means nothing to them. So what you want to do is use a secure, make sure that the password management software you use, once again, LastPass or KeePass are my recommendations, is using a secure encryption to encrypt the database of passwords. Then you're certain that you can just keep one strong password and have access to a secure database of other information for access. LastPass has a plugin for your browser so that it'll automatically fill those random strings for you. You don't even need to type in. You type in your master password, it fills all the stuff in for you. If you wanted to encrypt something like, say, a password that you do have to type in, though, you would need to pull up the program and look up the information.
Okay. Let me ask you, because your comments give me a little bit of concern in the length of a password. Several of my bank accounts, they limit me to 8 characters, and they limit to me that I can't use any special characters. So what do I do in that case? One, you maybe use LastPass,
Switch banks? That's just really bad security practice. There isn't really a lot to be said about that, but besides the fact that if your bank limits you to less than, to say 8 characters for your password, maximum,
2 of my accounts is maximum.
That's a very bad security policy. Now, one thing that you might run into, though, is say banks have been recently doing this, having a second factor of authentication. That's very good. Now, what that is you enter a normal password, and then it brings you to a second screen where you click on the letters for another password. What that does is that allows them to switch the image around and change it every time for a second level of authentication. Another good way to do that is there are cell phone applications like Google Authenticator is one, for example, that go onto your cell phone so that you enter the password. Not only do you need to enter the password, you need to enter a random code that's generated by your phone. Then you can access the account. This ensures that you need both the password and that physical device to access the account. So for really sensitive things like bank accounts, I recommend people use 2-factor authentication if possible.
So have we completely covered the topic of encryption and privacy on the internet? I mean, I want to make sure our viewers have a good understanding of the importance of it and how they go about doing it.
Yeah, I think that we've pretty much gone over the most major questions about it. Once again, I want to encourage people, though, to keep in mind that it isn't just encryption. Encryption is important, but you also need to use long passwords. You need to keep those passwords safe. You need to make sure that you're conscious of your information security and take care, because once people have the secret that you use, they can get in. So you have to use encryption, but keep your passwords secret and safe as well.
Well, just one last question. In most programs that you need a password, you also need a username. Should the username be as complex as the password?
It doesn't have to be. My recommendation is if you're using a device or a system that has a default username like administrator or admin, generally you should change that username, because there will be malicious applications, malicious programs that use the default usernames to try and hack in, which it will help you if you use something that's besides the default username, something that's not the default username. But usernames are far less important than the passphrase. The passphrase is the most important thing, and the most important thing is that passphrase be long more than it be complex. For example, like an 8-character long password that has uppercase and lowercase and symbols and all that is still far less secure than, say, a 14-character password that's all just lowercase letters. So make sure they're long.
Okay. Again, this presentation was really directed not only to the IT specialists within your company, it was designed for you, the CEO and management, to understand the importance of encryption and privacy when you're communicating using the internet. I want to thank you for watching this presentation. I'm Dwight Cromie with Energy Independence Magazine, and again, thank you very much, Adam.
Thank you.
Thank you very much.
The following presentation was made possible by the Alltech Media Group, a Southern California multimedia company providing exponential branding and marketing services to all their clients. The Alltech Media Group understands the value of the 3W strategy, providing their clients proven, trackable results. Let us make it easy for you to grow your business. Visit alltechmedia.com.